unit, we're going to talk about basic statistics and the different ways in which we can interpret data utilizing statistics. This particular lesson is going to focus on really honing in our terminology skills. So let's first start off by determining what is statistics. The science of statistics deals with the collection, analysis, interpretation, and presentation of data. Data describe characteristics of an individual, such as measurements, genders, survey responses, etc. There are two different types of statistics. We're going to cover descriptive statistics. Consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. However, inferential statistics uses methods that take results from a sample and extends them to a population, allowing us to draw conclusions from the good data. There was some population listed. So we must decide what is a population and what is a sample, and what is an individual. A population as a collection of persons, things, or objects that is being studied. An individual can be described as a person or object that is a member of the population being studied. So if we grab a bunch of individuals together, that becomes a sample. So a sample is a portion of the population that is being studied. A food inspector conducts inspections on a randomly selected group of 14 restaurants in Cookeville, Tennessee. Identify the population being studied and the sample chosen. Well, our sample is the selected group of 14 restaurants. And what are we doing? We're getting restaurants from specific Cookeville, Tennessee. So our population are all restaurants in Cookeville, Tennessee. So from all of those restaurants, we're doing 14 selected restaurants as our sample. A factory overseer selects 35 grape-flavored candies at random from those produced that week at the factory. Then he tests their quality, identify the population being studied, and the chosen sample. So we're selecting 35 grape candies from that week at the factory. So in particular, our population is going to be all grape-flavored candies in the factory, and our sample is specifically 35 grape candies. That leads us to talk about statistics versus parameter. A statistic is a numerical summary that represents a property of the sample. So a statistic is related to the sample, and a parameter is a numerical summary that represents a property of the population. So parameter goes with population, and a statistic is associated with a sample. Determine whether the given value is a statistic or a parameter. Suppose the percentage of all dog lovers in the United States is 74%. So we're talking about all dog lovers. This is a population, and thus 74% represents a parameter. Notice in part B, we have a sample of 50 town owners in particular state they were surveyed, and 64% of the people surveyed were dog lovers. 64% of the people surveyed is a sample. Thus, of that sample, 64% is a statistic. Now, not all statistics or parameters have to have a number associated with them. So let's look at part 2 here. A nutritionist wants to estimate the average number of calories consumed by children under the age of 8. From a random sample of 350 children under the age of 8, the nutritionist obtains a sample mean of 5,543 calories. We don't, in this particular statement, have a data value for the parameter. The parameter itself is wanting to estimate the mean of all children under the age of 8, the average number of calories. So the parameter is going to be the average number of calories consumed by children under the age of 8. However, of that, we do know the sample mean is provided. The sample mean is the statistic. Calories consumed by children under the age of 8. Let's try one more, determining the difference between parameter and statistic. A researcher wants to estimate the average farm size in Tennessee. A simple random sample of 500 farms, the researcher obtains a sample mean farm size of 475 acres. So sample, again, sample is the statistic, the population is the average farm size in Tennessee. So the parameter is the average and thus our statistic is the sample mean farm size of 475 acres. A variable is usually notated, A variable, usually notated by capital letters such as X and Y, is a characteristic or measurement that can be determined for each member of a population. Data are the actual values of the variable. They may be numbers or they may be words. Datum is a single value. Determine from all of the vocabulary that we've just used the key terms that refer to in the following study. We want to know the average amount of money first-year college students spend at ABC College on school supplies that does not include books. We randomly surveyed 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. So the population that we're looking at in particular is all first-year college students at ABC College. At ABC College. Our sample is the 100 that we selected. So 100 first year students selected at ABC College. The parameter, what are we specifically looking for? From our population, remember population and parameter are together. So from all of the first year students at college, ABC College, we're looking for the average amount of money first year students spend at ABC College on school supplies, not including books. Therefore, the statistic that we are collecting, the statistic is referring to the sample. So of those 100 that we sampled, what is the average amount that they spent? So of the 100 first-year students selected, what is the average amount, just kind of copying this whole sentence here saves some time here. What is the average amount of money first-year students spend at ABC College on school supplies, not including the books? The variable, what we're actually looking for, the variable is the amount. What is that amount that we're looking for? Amount of money those first-year colleges, that's what the data we're going to gather. Spend on school supplies, not including books. And then the data, what is the data that the actual values that we've collected? Well, we've only have 3 pieces of data, but the 3 pieces of data that we've collected thus far are 150, 200, and 225, the data themselves. This concludes our basic lesson on basic statistics terminology. The next lesson was going to talk about the different types of data that we have, quantitative or qualitative data, and go into a little more detail on that.